Okay, good morning students. So in this session we will discuss about the DFT and FFT. DFT, discrete Fourier transform, discrete Fourier transform, and what are the difficulties in DFT and what is why we prefer fast Fourier transform. Fast Fourier transform. Fast Fourier transform. In DSP, the discrete Fourier transform. So before DFT, okay, the DTFT, discrete time Fourier transform, discrete time Fourier transform, it is actually continuous time Fourier transform, discrete time Fourier transform, then discrete Fourier transform, then fast Fourier transform. Okay. So mathematical representations of the Fourier transform. So normally with respect to, we will differentiate these two also. What is DTFT and DFT and all? This is a continuous time and discrete time. So what is the continuous time, discrete time also? We will start from this one, no problem. So continuous time to CT to DT, how we can do? By sampling this T sampled into, okay. Normally the T is assumed to be 1. So now we will see the mathematical representations of all this one by one. So the first discrete time Fourier transform, okay. What is the Fourier transform equation? Discrete time Fourier transform, continuous, this is for CT, FT is continuous time Fourier transform, which will be integral of minus infinity to plus infinity x of t into e power minus j omega t dt. So the x of t is the time domain signal, the x of omega is the frequency domain signal, frequency domain by an integral transformation. In DSP, the discrete version of Fourier transform, this is continuous time Fourier transform, okay. The discrete time Fourier transform, the discrete version of Fourier transform is denoted by x d of omega. This integral form, this integral is transformed into discrete version summation. So where n equal to minus infinity to plus infinity, this t is sampled by n tau. So you can replace x of n tau into e power minus j omega, the t is replaced by n tau, okay, where t is equal to n tau and n is equal to 0, 1, integers 2, like that. So this integration is changed into this integration changed to summation in discrete version, okay. So and this t is changed into n tau. So now so if t is assumed to be 1, if t is 1, then you can write the equation, okay, xd of omega is equal to summation of n equal to minus infinity to plus infinity x of n into e power minus j omega n. This is the second equation. Second equation. So for this the inverse DTFT will be, you can write the inverse IDTFT will be x of n, you can write from this 1 by 2 pi, the integral of minus pi by 2 to plus pi by 2 x of omega e power j n omega d omega. Okay. So if you see this equation, the discrete time Fourier transform DTFT, this equation is DTFT. In this omega term, omega is not discretized. So consider the situation in this equation, for example this equation, where this omega is also, if omega is also discretized, in equation 1 the omega is also discretized by defining the relation, that is W is equal to 2 pi k by n. W is equal to 2 pi k by n, where k equal to 0, 1, 2 up to n minus 1. So now this equation, this DTFT equation, omega is discretized. Now this equation is modified as, okay, x of k is equal to summation of n equal to 0 to n minus 1 x of n into, this equation is modified, x of n into e power minus j, the omega is replaced by 2 pi by n, okay, into k n, where n is the total number of samples of x of n. So and this equation is called, discrete Fourier transform, DFT, discrete Fourier transform, So now what is the difference between DTFT and DFT? Here omega is not discretized, here omega is discretized. Okay. The second point, the lower and upper limits are minus infinity to plus infinity, but here the limits are, because the DFT values are periodic, with the period 0 and n minus 1. Okay, because the DFT values are periodic. With the period of 0 and n minus 1. So, in this DFT equation x of n, this e power, so okay, this w equal to pi k by n, w is discretized. Okay, so w, so you can write now x of k, this equation can be written as x of k is equal to the summation of n equal to 0 to n minus 1 x of n into e power minus j 2 pi by n into k, that is w, okay, n k DFT expression. K is equal to, k is equal to 0, 1, 2 up to n minus 1, where w is equal to the DFT equation. This is the DFT equation where the w is equal to e power minus j 2 pi by n. So, e power minus j 2 pi by n, w per n k. So, w per this e power minus j 2 pi by n. So, e power minus j 2 pi by n is called w. This w is equal to e power minus j 2 pi by n. This is called Twiddle factor. In DFT, this is called Twiddle factor. This Twiddle factor plays a vital role. Okay. So, because of this periodicity property of DFT, the calculations need to be done only between 0 and n minus 1. So, because this periodicity property, the calculations are required. The calculations need to be done only between the 0 and n minus 1. What is Twiddle factor, understood? Same. So, once if you know DFT equation, IDFT also I will write the equation IDFT. So, IDFT is equal to x of n is equal to 1 by n, the summation of k equal to 0 to n minus 1 x of k w power minus k n. So, here also what is w? E power minus j 2 pi by n. Okay. So, this is IDFT equation. This is the IDFT equation. IDFT equation. So, to compute endpoint DFT, to compute endpoint DFT, DFT requires n multiplications. To compute endpoint DFT, each DFT, okay, let it be. To compute endpoint DFT, each DFT requires n multiplications and n minus 1 additions. For endpoint DFT, it requires n squared complex multiplications and n into n minus 1 complex additions. So, because of this twiddle factor only, the w power k n is the twiddle factor. Because of this twiddle factor only, because of the symmetry property, there is a symmetry property, twiddle factor. So, it possesses the twiddle factor possesses symmetry property and periodicity property. We will see what is periodicity property and symmetry property. Because of this circular symmetry property, this is a circular symmetry property. The twiddle factor plays a circular symmetry property. So, which means the w power k of n plus n repeats periodically. It repeats periodically. With the period n. Okay, repeats k of n plus n repeats with the period n. So, the twiddle factor plays a vital role. So, if you see the DFT computations, the direct computation of DFT, okay, it requires more number of multiplications and more number of additions in the direct computation. So, in the DFT computation, for direct computation, we will solve one or two problems. Okay. How to compute direct computation? We will see the direct computation of the problems. DFT computation. Compute. Compute. I will explain the properties also. I will compute 4-point DFT example 2 0 0 1. So, what is k is equal to 0 1 okay 2 3 like that. So, it is k here 0 to n minus 1. So, n minus 1. So, n is equal to 4. So, this is n minus 1, 4 minus 1, 3. So, up to 0, 1, 2, 3. We have to calculate. So, what is the formula for x of k? So, x of k, what is the DFT direct computation formula? The summation of n equal to 0 to n minus 1, okay, x of n into e power minus j 2 pi by n into e power minus j 2 pi by n into k n. So, where w is equal to e power minus j 2 pi by n. Now, you substitute k equals 0, x of 0, first to x of 0. So x of 0 will take x of 0 is equal to k equal to 0. So if you substitute x of 0, k will be 0. K will be 0, e power 0 will be 1. So you will get x of 0 plus x of 1 plus x of 2 plus x of 3. So in this case x of 2 0 0 1. This is x of 0, x of 1, x of 2, x of 3. You will get 2 plus 0 plus 0 plus 1 is equal to 3. Similarly, you can find x of the next one is k equal to 0 1 2 3. X of 1 can be calculated the same way, n equal to 0 to 3. X of n into e power minus j 2 pi by n is 4. This is n. This is n equal to 4. J pi by 2 pi by n. Okay. K is this is k value. K value is 1 into n. So you can simplify n equal to 0 to 3 x of n e power minus j pi by 2 into n. Okay. So again you can reduce the equation, summation of n equal to 0 to 3. Okay. So you substitute x of 0 into e power 0 and t power 0 1. This will be 1 first term. Second term will be x of 1 into e power minus j pi by 2, n is 1, plus second one x of 2 into e power 2 e power minus j pi plus x of 3 into e power minus j 3 pi by 2. Simplify again. What is x of 0 value? X of 0 value is 2, no, plus other terms and all 0. The last term will be 1. What is the x of 0? 0. This is x of 1. This is x of 2. This is x of 3. So x of 3 only 1. So 2 plus e power minus j 3 pi by 2. So you can write 2 plus cos 3 pi by 2 minus j sin 3 pi by 2. So you can write 2. So this cos 3 pi by 2 minus j sin, so minus j minus 1, you will get minus of minus plus j. So plus j, 2 plus j. So x of 1 is equal to plus 2 plus j. Similarly, there was other next case, x of 2 is equal to the summation of n equal to 0 to 3 x of n into e power minus j 2 pi by 4, that is 2 pi by 4, n is 4 into k into n. K is 2 into n. So it will be cancelled here. Okay. Now you can simplify this equation. So minus j pi by n. So x of 0 x of 0, this will be, any substitute x of 0 to be 1 plus the last term x of 3, so k will be, so you will get e power minus e power minus 2n, this is e power minus j 3 pi k into n, so n will be 3, so e power minus j 3 pi, so you will get 2 plus, so e power minus 1, this is 1, so 1 into e power minus cos 3 pi minus j sin 3 pi, so you will get which is equal to 1. Similarly, the last term will be x of 3 will be the summation of n equal to 0 to 3 x of n into e power minus j 2 pi by n is 4 into kn is 3 into n, so we will get to 3 by 2. So you can simplify, so 0 x of 0 plus x of 3 into e power minus j 3 pi by 2 n, e power minus j 3 pi by 2 by 3 pi by 2 into 3, so 9 pi, so we will get this will be x of 0 plus x of 3 into e power minus j 9 pi by 2, correct. So then you can write, simplify x of 0 plus x of 3 is 1, this is 2, no, so this is, substitute the equation, substitute x of 0 value is 2, 2 plus x of 3 is 1, so cos 9 pi by 2 minus j sin 9 pi by 2, so this is equal to 2, this is minus j, this is minus j, you will get, so what is that final equation? Compute 4-point DFT for the given sequence. So x of 0, so final answer is, first one is 3, 2 plus j 1 comma 2 minus j, this is the direct computation of DFT. Okay, x of k is the final answer, x of 0, x of 1, x of 2. So I hope that you understood. It's a direct computation, okay, but we will switch over to the FFT because the direct computation involves more number of multiplications and additions, okay. So in order to reduce the direct computation, the fast Fourier transform was developed. Similarly, you can the convolution of DFT, okay, so I will give another example, you can practice. So problem 2, the same way you can practice, compute compute 4-point DFT 0, 1, 2, 3, okay, the same way you calculate. And here the convolution by using matrix method. I will explain the matrix method also, how to do the DFT 4-point DFT by using matrix method. So that also I will explain. So DFT and IDFT also will now solve now. Matrix method. DFT using matrix method. Sometimes the 4 marks questions you can expect the 4-point DFT by using matrix method. So this can be represented x of 0 and x of 1 up to x of n minus 1, okay, can be calculated. It is equal to W0 n W0 okay n W0 n W1 n up to W0 n W n minus 1 W0 Wn minus 1 is 1 2. So similarly Wn n minus 1 into n minus 1. So because we need to constrain for the FFT, so just I will tell you how to calculate by using matrix method in a simple way. Okay, x of n minus 1. For 4-point can be written as x of 0, x of 1, x of 2, x of 3, which is okay is equal to so 1 should be 0. If you calculate, it will be 1 1 1. This is W1 minus j minus 1 j minus 1 1 minus 1. If you calculate j minus 1 minus j, this you remember. Okay, then what is the sequence they given? Example, for example, x of n is equal to 1 2 1 0. Okay, so n is equal to 4. So in that case you write 1 2 1 0. So you will get, multiply these two. So first one 1 2 1 3, okay, 1 2 1 0. So 1 plus 1 2 1 3 3 plus 1 4. So you will get the values are 4 minus j2 0 and j2. This is a matrix multiplication. Okay, so x of k is equal to 4 minus j2 0 plus j2. So the simple direct computation. Okay, similarly for DFT. So what is DFT matrix method? Sometimes, so this is x of k, okay, x of k. So 4 point DFT using matrix method. Similarly, the 4 point DFT using DFT to find IDFT using matrix method, IDFT, okay, using matrix method, for that you take complex conjugate. The step 1 is 4 point, okay. Step 1, take conjugate term, conjugate of the sequence, to get the complex conjugate term for the given sequence. Same using this DFT. This is the, now you take, this is the problem. DFT is given, this is the DFT, okay. So this DFT has given us a problem for you. This DFT has given a problem for you. For this DFT, how to find out the, okay. So using this DFT to find the IDFT. So the IDFT of x of k is given. So IDFT for this equation. So DFT find, no, so you have to find IDFT equation. So this IDFT, you have to find IDFT of. So now the problem is find IDFT of this DFT sequence. X of k is given. Problem is find IDFT of this DFT. X of k is given. Take complex conjugate. Then take complex conjugate means which is equal to, so 4 complex minus j2 will become plus j2, 0 plus j2 will become minus j2, plus j2 becomes minus j2, minus j2. This is a complex conjugate terms. Now step 2, find the DFT of the complex conjugate of k using 4 by 4 DFT matrix. So the DFT of the complex conjugate of k is equal to, say, matrix method 1 1 1 1 1 1 minus j minus 1 plus j 1, this is minus 1 minus 1 j minus 1 minus j. Then what is the complex term you taken? 4 j2 plus j2, 0 minus j2, okay. Okay, then if you multiply these terms and these terms, you will get 4, j square means this is 8, this is 4, this is 0. Okay, first term, second term multiply in, will get, for example, I will show that multiplication 4 plus j2 plus 0 minus j2. So you will cancel these two, so you will get 4. Second term will be 4 j square minus of minus plus 1, so plus 2, then 0 minus j square minus 1 plus 1, so plus 2. you will get 8. So third row, this is third row. If you get now 4 1 4 minus j2 minus 2j, you can say third one 0 plus 2 minus into minus plus 2j. So you will get minus 2j plus 2j cancels, so you will get 4. The last term will be 1 into 4 4. Okay, j into j square minus 1 is minus 2, and third term will be 0, fourth term minus 2 minus plus j2. So minus 1 plus j square minus 1 minus 2, this is minus 2. So plus 4 minus 4 will be cancelled, it will be 0. So this term equal to 4840. Then final step 3. Step 3 is conjugate the result again. Conjugate the result. If it is a complex, if complex you are getting, if complex terms, and divide by n, and divide by n equal to 4 to get the IDFT of x of k. So IDFT of x of k is equal to 1 by n is 1 by n, no? So 1 by n of 4 comma 8 comma 4 comma 0, which is equal to 1 by 4 of 4 comma 8 comma 4 comma 0, which is equal to 1 comma 2 comma 1 comma 0. This is the answer. Okay, so the 4-point DFT. So how the derivation has come now, you can refer the prescribed book. Here only we solve some examples for finding out the DFT and IDFT using direct method. Okay, using direct method and the matrix method. Okay, so next section we will see the FFT algorithm.